All right, exam 1, problem 1. We have two vectors, vector A, vector B. Vector A is 2 meters long, makes an angle of 30 degrees with the horizontal. Vector B is 3 meters long and makes an angle of 45 degrees with the horizontal. And part A of this is to analytically determine the result of adding A plus B. All right, so we want A plus B analytically. All right. Well, let's start with what is A. We can look at A as, all right, it's 2 meters times the cosine of 30 degrees, all right, in the I hat direction, all right, in the x direction, plus 2 meters times the sine of 30 degrees in the j hat direction, or y direction. Is that clear? A is a combination of two components, right? The component in x plus the component in y. And those two pieces make up A, and they are determined from A times the cosine of the angle, 2 meters times the cosine of the angle, plus in the I direction, plus 2 meters times the sine of the angle in the j direction, right? Okay. What then is B? B, very similarly, is 3 meters times cosine of 45 degrees in the I hat direction, plus 3 meters times sine of 45 degrees in the j hat direction. All right? So if you're going to add these up, analytically, what you're doing is you're adding these two pieces that are in I and these two pieces that are in J. So you're adding up those two bits. Let's turn to Excel really quick and go ahead and get what these values are. Okay, 2 meters, 2 times the cosine of radians of 30 degrees. So that is 1.73, and 2 times the sine of radians of 30 degrees. And that's 1. So this is 1.73 I hat plus 1 j hat. Let me stick the meters back in. I forgot those. Okay. And then in B, this is 3 times the cosine radians of 45, 2.12. And the other should be the same because cosine and sine of 45 degrees are equal. 3 times the sine, radians, 45, 2.12. So B is 2.12 meters I hat plus 2.12 meters j hat. Okay, so now we have the I components and the j components, and we're looking for what is R, which is the sum of the two. And so 2.12 plus 1.73, right? So the x components added together and the y components added together. So we have 3.85 and 3.12. 3.85 meters I hat plus 3.12 meters j hat. That is analytically, that is R. Okay, so this was part A. Now part B. Part B is what is the magnitude of R, right? So the magnitude of R is given by the square root of the sum of the squares of the two sides. That's going to be in meters, right? So equals the square root of 3.85 squared plus 3.12 squared, 4.96. All right, and that doesn't have a direction. That's just the length of r is 4.96. And part C is determine the angle r makes with the horizontal. Okay, so what does r look like? R is 3.85 this direction, and then 3.12 that direction. So r is like that. We're looking for this angle that it makes with the horizontal. So tangent of that angle is y over x, right? Tangent of that angle is y over x. So what we're after is the inverse tangent of the y piece, which is 3.12, divided by the x piece, 3.85. Okay, so what is the inverse tangent? Turning back to Excel, a tan of, no, I'm going to type it in, 3.12 divided by 3.85. Again, Excel uses radians, so this is going to be in radians, not in degrees. So we convert to degrees with the degrees function, and we get 39 degrees. All right. So theta is 39 degrees above the horizontal. And that's it for problem 1.